one other thing to notice. So any linear block code must contain the all zero code word, and that's because of this. If I multiply on the left by the all zero message, that'll just wipe out all of the columns, and I get the all zero output code word. So for Mark 2, any linear block code contains the all zero code word. So, another thing to notice here. Let's say C1 and C2 are code words of a linear block code. Then C1 plus C2 mod 2 is also a code word. So this is a claim, proof. Well, if C1 and C2 are code words of a linear block code, then there must be some M. So M1G is C1, and there must be some M2G at C2. So therefore, C1 plus C2 is equal to M1G plus M2G. Matrix multiplication is distributive, as is mod 2 arithmetic. So therefore this is M1 plus M2 times G. This could be done mod 2. So if this is mod 2, M1 is a sequence of k bits, M2 is a sequence of k bits. If I add them up mod 2, I get another sequence of k bits. So therefore there must exist some M multiplied by G to generate C1 plus C2. So that's actually quite neat. So any, if I start with a code word and I add any other code word, then the result is a code word. So one thing this indicates straight away is that if the error pattern comes in the form of a code word, then that error pattern is not detectable. So this property also, let me just mention this very quickly, and then this will be the last thing that I mention. The minimum Hamming weight, minimum weight code word, actually, excuse me, let me back up. The Hamming weight of a code word is equal to the number of ones in the code word. Let's call that W of C, where C is the code word and W is the Hamming weight. And furthermore, there exists W min, which is the minimum over all C in the code of WC, and we call that a minimum Hamming weight. So it turns out, for a linear block code, d min is equal to w min. So that's actually a really nice property. So think about how you would get d min. Basically, you'd have to compare every code word pairwise to look at the distance between them. And that would have complexity of the number of code words squared. Here, w min can be obtained just by looking at each individual code word. Why is this true? This is true because of the additive property. So since C1 plus C2 is in the code, then the distance between C1, the Hamming distance between C1 and C2 is equal to the Hamming weight. So think about how this works. The Hamming distance between C1 and C2 must be the Hamming weight of C1 plus C2. That's because if I take C1 plus C2 mod 2, I get a 1 where those two code words are different, and a 0 where they're the same. So therefore, the number of places that they're different is equal to the Hamming weight of C1 plus C2. Since C1 plus C2 is always a code word, the minimum value of C1 plus C2 is the minimum Hamming weight. But this is also the minimum distance. So the minimum on this side is the same as the minimum on this side. I will go back over that with an example next class. Are there any questions? Okay, so next time we'll pick it up here, and I will tell you about a famous linear block code called the Hamming code.